Hello everyone. Hello everyone. For this tutorial video, I would like to explain factors that affect resistance to flow, both within the container of the fluid and within the fluid itself. Since we remember that fluids have zero resistance to perpendicular forces, we can guess that the fluid will constantly or continuously move, as long as a perpendicular force is applied. While this is true, this is not a universal constant for all types of fluids. Some require more force than others because they produce more friction. In particular, the longer the fluid will flow through something, the more overall friction it will encounter against the solid surface of the container, and the wider the container or other path the fluid travels through, the less friction it encounters because the less it has a statistical chance to run into the solid container. However, the geometry of the container is not the only answer as to what causes friction, as the physical properties of the fluid itself also play a part. In particular, the thickness of the fluid determines its resistance to flow. So because water is very runny, it flows easily, whereas something like soap is more thick, and so flows much less. In more technical fields, you will hear the thickness of a fluid is called the viscosity. So a thick fluid is also called a viscous fluid. Mathematically, these basic factors can be written as force that is required to move a fluid equals thickness times the velocity produced by the force times length all over cross-sectional area. Since we have determined what factors affect resistance to flow, we can state flow rate in terms of resistance as well. In particular, flow rate equals pressure difference, or pressure at point 2 minus pressure at point 1, divided by resistance, since we know a pressure difference causes a fluid to flow, as proven in the last tutorial video. A more mathematically exact answer is provided by something called Poissier's law, after the French physicist J.L. Poissier, and is stated as flow rate equals pressure difference times pi times r to the fourth power divided by 8 times thickness times length. However, this only works with fluids in a circular path, such as through pipes, tubes, or similar conduits, because the r to the fourth power means radius, and so something without a circular shape cannot have a radius by definition. Studying the friction of different types of fluids explains why water is used in the home plumbing systems, because water has a very low thickness, so it flows easily. An effect of this type of friction is that the flow through a pipe or similar device is that the flow through any type of container will be weakest at the parts where it is against the walls of the container, i.e. where it encounters the most friction, and will be greatest at the center of flow, as that is where it is geometrically the farthest away from both solid ends of the container, as you may have already observed by dropping sticks in a river. Although flow rate equals pressure difference divided by resistance is valid for any type of flow, whether straight line or turbulent, Poissier's law, the more exact answer, only works for straight line flows, because turbulent flow introduces more factors that Poissier's law does not cover, owing to the random motion and random distribution of the swirls inside the fluid. In the next tutorial video, We will study factors in the fluid itself that cause turbulent flow, such as irregular shapes of the container that redirect the flow, or high speeds within the fluid that are independent of the container, that cause the layers to drag upon each other and produce turbulent swirls as a result. Don't forget to subscribe if you found this video informative, and make sure to see other tutorial videos, and follow me on either Facebook or Twitter for more content.